Hello to you all. Last time we were able to discuss about Newton's first law of motion, and there were four important areas that we were supposed to remember. First, to state the Newton's first law. Secondly, to give the meaning of inertia. 3, to define force according to Newton's first law of motion. And then we ended up talking about momentum. I'd like to ask Abdulhamid to give us the meaning of force according to Newton's first law of motion. What is force? Yes, Ibrahim, can you try? What is force?
Mr. Sifuna?
Yes.
Yeah, you are a co-host, Mwalimu. You have the authority to unmute any person.
Yeah, I'm doing that.
Okay, thank you.
Yeah, students, I told you when we talk, exchanging ideas, what you can remember, it's how we shall remember the physics. So I'm asking that we define force. What is force according to Newton's first law? In Form 1, we know that force is a push or a pull. But now, according to Newton's first law, what did we say is a force? Anyone? John? What is a force according to Newton's first law of motion? Okay, remember from the two states, according to Newton's laws, the first state is the state of rest. The second state is the state of motion. And then we said that a body will always remain at rest or in uniform motion unless an external force acts. You see, we are saying unless an external force acts. So this body will remain at rest or will continue being in motion unless an external force acts. That means that a force is that which can change the state of rest or of uniform motion of a body. Please remember that which can change the state of rest or of uniform motion of a body. Now, the other key area or key point that you're supposed to know is the meaning of inertia. What is inertia? Yes. Abdi Malik?
Tendency of a body to remain at rest.
Tendency of a body to remain at rest. That's a good try. What about to remain in motion? So Abdi Malik, that was correct. That inertia is the tendency of a body to remain at rest, but was supposed to add something, or in uniform motion. Tendency of a body to remain at rest or in uniform motion. Guys, I would like you to understand this topic. You see, according to the KCSE as at now, Form 1, Form 2, Form 3, just to share with you, it's likely to carry 80%. Form 4 might only be 20%. So a topic like Newton's laws, linear motion, quantity of heat for paper 1, those are the topics you're supposed to master very well. So as we are going on, just these simple questions I'm asking you might be the same questions you might come across. So the meaning of inertia, what is a force according to Newton's first law? So you must look at the question. Have they asked generally what is a force? If they say define a force in relation to Newton's first law of motion, then it means you must bring in the aspect of that which can change the state of rest or of uniform motion of a body. Now, we had a simple question that we discussed last time. I want to see who still remembers this question here. We had this. We had this mass. We had a mass which was suspended here. And we had a string there. So we had this part. This was A. This was B. And then we said that this mass here the string was pulled down slowly and then pulled down suddenly. What happens when the string is pulled down suddenly? Yes, and then try. Those are the questions I'm asking. Yes. So when the string is pulled down suddenly, what do we observe? Abdul Malik, once again.
B will cut due to inertia of rest, which the mass tends to resist the change in motion.
The mass, due to inertia, the mass tends to resist the change from rest to motion. Baja. Abdul Malik, the first answer is correct. Baja is answering for us Roman 2 when it's pulled down slowly. Baja, your hand was up.
Experience a sudden change.
You're answering Roman 2. Okay. Baja, which question are you answering? The first or the second? Just repeat your answer.
The second.
Okay. Now repeat your answer.
B will cut because the mass will resist the change from motion or rest.
She says that B, when you pull down slowly, B will cut because the mass will resist the change from rest to motion. You see, that's what happens. We have to understand the question. That's a good try. Remember, I've interchanged. The answers we had last time, we started by talking about slowly, then followed by suddenly. So Baja has given us for the first one, suddenly. So be very careful. Abdul Malik, you want to correct something? Go ahead.
When B is pulled slowly, A will cut because it is experiencing a higher tension.
Good. A will cut when you pull slowly because it will be experiencing higher tension. So please be very careful. When you pull down suddenly, that means faster. That's when the mass will resist the change of state from rest to motion. So B will cut. And I agree with Abdi Malik that when you pull down slowly, A experiences higher tension. So it will have to cut. Okay. Now, we move on. We had talked about momentum. Okay. So Newton's first law is also known as the law of inertia. Remember that. And mass of a body is a measure of its inertia. A body which is heavier or is of a larger mass will experience a greater inertia than the one which is smaller. So a smaller mass will experience less inertia, but a larger mass will experience larger inertia. Now, when we started talking about momentum, we were able to define momentum, and we looked at three factors that affect momentum. So momentum, we defined it as a product of mass and velocity. And then we mentioned factors that affect momentum. I want one of you to just mention the three factors at once. Three factors that affect momentum of our body. Yes. Three factors that affect momentum of our body. Anyone who can remember? You see the product of mass and velocity. So what are these factors that will affect momentum? Okay. Yes. Baija, your hand is up.
Changing velocity, changing mass, and changing direction.
Very good. Change in velocity, change in mass, and change in direction. So many of you have put up their hands. That's very good. So those are the three factors that affect momentum. Now, momentum can change per unit time. If momentum changes per unit time, it takes us to what we call Newton's second law of motion. But before we go to Newton's second law of motion, we have some worked examples here, which I would like you to attempt. Number one, we have a van whose mass is 3 metric tons. It's traveling at a velocity of that. Calculate the momentum of the vehicle. So you can quickly copy the question, then attempt, or just do the working, because these notes you will be given. Just show the working, you will be given the notes. So when you're working out, try to work out in SI units. You convert the 3 tons to kilograms, convert the kilometers per hour to meters per second. One more minute. Okay, now let's see the working. Check if you are right. Fatma, what have you found to be your answer? Fatma Mohammed, what's your answer for that question? Kasim? Anyone who has got it right? So the 3 tons, we convert to kilograms, it must give us 3,000 kilograms. Then what is 72 kilometers per hour? What is it in meters per second, Kasim? Yes, Reda Hassan? Just unmute yourself and talk, Reda Hassan. Your hand is up. Okay. So in this case, step-by-step solution, the mass of the van we convert to kilograms. This will be 3,000 kilograms. Then the velocity, it will be 20 meters per second. So when converting velocity from kilometers per hour to meters per second, so if it's kilometers per hour to meters per second, what are we supposed to do? This is equal to, you take what you're given, then you multiply by 5/18. So you are converting kilometers per hour to meters per second. Take what you're given, like now 72 kilometers per hour, just multiply by 5/18. And if you are converting meters per second to kilometers per hour, and then in this case, you multiply by 18/5. And here you multiply by, so that's how we do the conversion. Kilometers per hour to meters per second. You take now, like in this case, we have 72. So 72 multiplied by 5/18, it will give us 20 meters per second. But if you are converting meters per second to kilometers per hour, multiplied by 18/5. So from a bigger unit to a smaller one, take smaller over bigger. But from smaller to bigger, then take the bigger over the smaller one. So after the conversion, you now multiply and we get the answer to be kilogram meters per second. So please, you can put down, that's the working for that question. Okay. Now let's see, there is another example. Yes. How do you do that? Let's now attempt that. Don't copy the question, just show the working, because this notes will be given to you. Just show the working only. It's a good question which requires you to reason. What velocity will double its momentum? Abdulhamid? Yes, Abdulhamid, your hand is up. What have you got? Unmute yourself. Unmute yourself and then talk. Okay, you're excited to lower your hand. Your hand was up. Kasim, you want to try to give the answer? Anyone who wants to try and give us the answer? Okay, that's good. Okay. Lamita, I've got your message. Your answer is 20 meters per second. Okay. Lamita has got the answer to be 20 meters per second. Another person. Abdishakur, what are you getting as your answer? So Abdulhamid should be right, because that 6 kilometers per hour, when you convert to meters per second, it's 10 meters per second. So for momentum to double, the velocity must double. If the mass remains the same, then if momentum is doubled, velocity will also double. So look at this working. Velocity v of the car, the initial velocity. So we are converting that 6 kilometers per hour to meters per second. And then let the mass of the car be in kilograms. Then momentum is mass times velocity. So here, this will be 10 m kilogram meters per second. That will be the initial momentum. We don't know the mass. Let the mass be m. Now, doubling momentum, you take this momentum now, multiply by 2. So we double the momentum. So we get 20 m kilogram meters per second. So if v is the velocity, so we don't know the velocity. So that means now we take mass times velocity should be 20 m kilogram meters per second. But now m and m will cancel out, then we remain with v to be 20 meters per second. So in short, if the mass remains the same and you are doubling momentum, just double the velocity. If velocity is the same and you are doubling the mass, I mean you are doubling momentum and the velocity remains the same, then you double the mass. Just remember that momentum is mass multiplied by velocity. So if they say momentum is halved when velocity remains the same, then you take the mass divided by 2. That's also acceptable. This is how to go about that question. So Malik, that was good. You got it right. Okay, now that takes us to Newton's second law of motion. Those are just examples for you to understand how to calculate momentum and anything to do with change in momentum. So Newton's second law is talking about the change in momentum per unit time. So momentum can only change if the mass changes. Momentum can only change if the velocity changes. And momentum can only change if there is change in direction. And for these changes to happen, there must be an external resultant force. Because if the body is in uniform motion, it will continue being in uniform motion unless an external force acts. So that's why now Newton's second law of motion brings in an external resultant force. Our body was moving, but now there was an external force that caused a change in momentum. So the Newton's second law states that the rate of change of momentum of a body is directly proportional to the resultant external force. So this resultant external force is what has caused the change in momentum. And the change takes place in the direction of the force. If you can just quote that Newton's second law in your notebook. Now, for you to remember any law, you must learn to say it loudly, you verbalize it, you speak it. If you don't speak a law, you can't recall it. So the rate of change of momentum of a body is directly proportional to the resultant external force producing the change, and it takes place in the direction of the force. I want all of us, you don't unmute yourself, but wherever you are, I want all of us to say the law from the start. Okay, we go. Apply early, I've not seen you stating the law. Apply early, I've not seen you stating the law. Please, let's state it verbally. Apply early, can you read the law loudly? I want also to hear and mute yourself. Okay, read it now.
Change of momentum of a body. The rate of change of momentum of a body is directly proportional to the resultant external force producing the change and take place in the direction of the force.
Very good. So for you to remember any laws, please learn to verbalize. You read them loudly. So according to Newton's second law, please, we are talking about change in momentum per unit time. So the change in momentum, it means we have final momentum minus initial momentum, which is the same as mv minus mu. So this you can be asked in the exam to show that F is equals to ma. So this is how we start it. You start by stating Newton's second law, that the rate of change of momentum is directly proportional to the resultant external force producing the change and takes place in the direction of the force. Then you come and define what you call change in momentum, mv minus mu, rate of change of momentum. Whenever you come across the term rate, it means divide by time. So mv minus mu over t. And then from Newton's second law, that the rate of change of momentum is directly proportional to an external resultant force. So this is the resultant force. And then this is the rate of change of momentum. They are directly proportional. So that's how we bring in F. Now, but acceleration is changing in velocity over time. So when you see v minus u over t, that is the same as acceleration. So that brings you to F is equals to ma. I just want to go back again. This is a possible question in your KCSE. Show that F is equals to mass times acceleration. So you have to start from Newton's second law, talk about change in momentum, then talk about rate of change of momentum. Then from Newton's second law of motion, F is directly proportional to m. Yes, that way. Those I'm seeing they're making some short notes. I can allow you to make the short notes. Okay, so what is important is this force we are calling the resultant force. You have to know that at this point here, F is equals to, there must be a constant K MA. Because when we remove this constant of proportionality, then we replace it with a constant K. This constant K, we must find it. In the final equation, you find that K is not existing. Remember that. Formula and variation mathematics form 3. When you remove this constant of proportionality, you must give a constant. So this constant, how do we eliminate it? By defining a Newton. So if this force is 1 Newton and the mass is 1 kilogram and the acceleration is 1 meter per square second, then K will be 1. I repeat, I want us to remove this K. To remove K, we define a Newton. What is 1 Newton? 1 Newton is a force that will give a mass of 1 kilogram, an acceleration of 1 meter per square second. So this is 1 Newton, then equals to, it will give, so this is K, then multiply by 1 kilogram, then this multiply by 1 meter per square second. So that's how we define a Newton. 1 Newton is a force that will give a mass of 1 kilogram, an acceleration of 1 meter per square second. So in this case, 1 is equals to K times 1 times 1. Therefore, from that we conclude that K is equals to 1. So if K is equals to 1, then that's how we conclude that, therefore, F is equals to MA. Because now in place of K, we have put there 1. So 1 times M times A, so we find that F is equals to MA. Okay. So I want you to write down the meaning of a Newton. What is 1 Newton? 1 Newton is a force that gives a body of mass 1 kilogram. I'm defining a Newton. 1 Newton is a force that gives a body of mass 1 kilogram, an acceleration of 1 meter per square second. That's what we call a Newton. Okay. So that's how we arrive at F is equals to mf. Now I want to give various names to this force F. This force F is a resultant force. That's the first meaning we should know, is a resultant force. That force, because we are defining Newton's second law, that the rate of change of momentum is directly proportional to an external resultant force. So in the exam, when they ask you a resultant force, then it means you'll take mass multiplied by acceleration. Now, that force, we can also call it accelerating force. Can also be known as an accelerating force. So it can also be decelerating force. It can also be known as impulsive force. So whenever they ask you to find the resultant force, find the accelerating force or decelerating force, or find the impulsive force, this is the same, we use the same formula. Now to talk more about impulsive force, if we have that, we have F is equals to mv minus mu. So let's say this in brackets, and everything is over T. I want to talk about this as the formula for impulsive force. This down one, mv minus mu over T. Now, take for example, you hit your fist on the wall, and you hit your fist on a mattress. In the two cases, one of them will be more painful, but another one will not be painful. If you hit a wall and you hit a mattress, hitting a mattress is less painful, but when you hit a wall, it's more painful. What could be the reason to that? I know we have all experienced that. Hit the wall, it's very painful, but hit a mattress, it's less painful. Any explanation to that? Okay. Let me try. So I want to use that question to explain to you what we call impulsive force. When you hit a wall, look at this T. So we are looking at the rate of change of momentum. When you hit the wall, your fist will take the shortest time to stop. It will be stopped instantly. But when you hit a mattress, it compresses in. So it takes some time before your hand, if you are using your hand to hit the mattress, it takes some time before the hand stops. So the time taken when you hit the wall is very short. And when that time is very short, so the change in momentum per unit time will be very high. So that's how you feel the pain. But if you hit the mattress, it takes some more time before your hand stops. And because the time is longer, so it's a numerator. Because the time is longer, this force will be less. So hitting a mattress, you will experience less impulsive force because of the prolonged time. But when you hit a wall, you will experience higher impulsive force because the time taken is too short. For the same reason, when footballers are playing football, we have a goalkeeper, we have the players. When somebody hits the ball hard and the shot comes moving very fast, the person stopping the ball does not stop the ball instantly. The person tends to withdraw the foot backwards. When withdrawing the foot backwards, you increase the time of impact. So as the ball hits your foot, you try to withdraw the foot so that the time of impact is prolonged. So there, the impulsive force will be less. So you'll not feel the pain. But if you stop the ball instantly, that means you have not withdrawn the foot. The ball will go back, but you'll feel some pain because the time of impact was too short. I'm emphasizing what we are referring to as impulsive force. Impulsive forces can cause pain. I want to give another example. Those who play volleyball, when somebody is going to receive a volleyball ball from a ball which is moving very fast, they tend to withdraw their arms backwards. Withdrawing the arms prolongs the time of impact, and that reduces the impulsive force. Looking at a car has what we call, some people call them shock absorbers, but they're not shock absorbers. We have the airbags. We refer to them as the airbags, where the driver sits and the co-driver for the cars, the private cars, we normally have the airbags. Now, when a car has head-on collision, to reduce the impulsive force, that's the pain that the person is likely to experience, you will find that there is an airbag. So if you put on the seat belt, the safety belt, when you wear it, the safety belt in the course of the accident will cause the airbag to come out when it is full of air. So somebody's chest will bounce on that airbag. That means the time of impact will be longer. So this person will not be injured seriously. But if you don't put on the seat belt or the safety belt, that means in case of head collision and you are the one holding the steering will hit your chest and it will take the shortest time. So the impulsive force we'll experience will be higher. So, guys, I'm just talking about force is equals to mv minus mu. That's change in momentum divided by time. So if the time of impact is going to be longer, then the impulsive force will be less. But if the time of impact is shorter, then the impulsive force will be greater. So in the exam, what kind of a question do you expect there? An application question. And I've given examples of an application question. When a bird is flying in the air and it wants to land, let's look at like a flamingo. These birds which have long legs. When a flamingo lands on the ground, you will find that they flex the knees, the knee point. They will flex. Why do they flex? To prolong the time of impact. When making the time of impact to be longer, the impulsive force will be less. So those are the kind of questions on Newton's second law of motion, application questions. When you are jumping from a high place, you are going for long jump or you are going for high jump, what happens? They always place a mattress for you to land on the mattress or on soft ground, so that as you land on that mattress, the mattress will compress in. That compressing in of the mattress prolongs the time of impact, therefore reducing the impulsive force. So I'm giving you 2 minutes to write what you have understood as live example for Newton's second law. 2 minutes. Emphasize talking about time of impact being longer, being shorter. How does it affect the impulsive force? So an example of a question for Newton's second law of motion. So we have this as the acceleration, we have this as the force. So we are being asked to find the mass. So we simply substitute in the formula that force is mass times acceleration, and then we find the mass directly that way. So remembering the formula is what's important. F is equals to ma. Another example there. Yes, can you work out that for a minute? Write the formula, substitute in. So this truck weighs 1.0 times 10 power 5 newtons. Okay, let's go back to the previous question shortly. Baija has already got it to be 15,000. Someone has requested I go back to the previous question slightly. This is the question. They're asking for what mass? So whoever has wanted us to go back to the previous question and say this. We are simply using the formula F is equals to ma. So you can see the force is given 125 newtons. Then acceleration is given. So we are looking for the mass. And I want to believe that we know how to use the triangle of formula. Please remember to use the triangle formula. This triangle is normally very useful. So like now in this case, we are talking about force. So you can put F up here is mass times acceleration. Mass there. Then we put acceleration here. So this is how you'll be arranging them. becomes very easy. If you want to find force, you cover force, then this will be multiplication. So at this point here, this is normally multiplication. And this is normally divided by. So force mass times acceleration. Then acceleration. So when you cover acceleration, then it means acceleration is force over mass. When you cover mass, so mass is equals to force over acceleration. So that's mass is force over acceleration. Then you find this. So now we go to the next example. I believe whoever wanted us to go back to that has understood something. So this was the next example. What force will give an acceleration of this? So from that triangle formula, what force? Force is mass times acceleration. Baja had already given her answer to be 15,000 newtons. So now confirm. So she was right. So 1.5 times 10 power 4 newtons is the same as 15,000 newtons. So Baja got it right. And I know most of you got it right. So first of all, where they say the truck weighs these newtons, convert this to mass. So I know that there are those of you who confused and took this 1.0 times 10 power 5 newtons as the force. But you see, they are asking for what force? So if the truck weighs this, that's you convert this to the kilogram, then you work out to get that as the answer. Okay. And move on to the next example. Given petroleum mass 1.5, it's pulled along by an elastic cord. It's given that acceleration. So find the frictional force. So Fatma has already got frictional force to be 3 newtons. Let's see what the others are going to get. That's good. And there is a force pulling to the front. And let's take that there is another force. Those frictional force will always act in the opposite direction. So that is, we take this to be the frictional force. So find the frictional force acting on the trolley if the tension in the cord is 5 newtons. So this one here, the tension here, we are taking this to be 5 newtons. And if you are given the answer, 2 newtons, 2 newtons. John has given 2 newtons. Abdi Malik, 2 newtons. Okay. Fatma, 2 newtons. Okay. Abdi Hamid. Abdi Hamid, I'm not seeing your answer. Okay, most of you have got 2 newtons. 2 newtons, Baja 2 newtons. So Baja has changed from 4 to 2, 3 newtons. Okay, let's see who is right. So this 5 newtons. And this is 1.5 kilograms. So that's the mass. And then, of course, frictional force will act in the opposite direction. This is friction. Okay, many of you are sending in the answers. That's good. So, a resultant force F is equals to MA. So in this case, our resultant force will be 5 newtons minus friction this should be equal to 1.5 multiplied by the mass, that's the mass multiplied by the acceleration, which is 2. So from here on the right hand side, so this will be 5 minus this is 3. So that means our frictional force, that will be equal to friction. Very good. So those of you who got 2 newtons are very right. Clap for you, that's nice. So 2 newtons. So you see, when we call that resultant force, that's how we work out. You show the subtraction part. This is to be our last example. Congratulations for those of you who got the answer right. This is our last example. Once you finish, you can send that message. Okay. Oh, you need. Yes, okay. I'm just sending the answer. So you calculate the average retardation of the car and the average force. So I expect 2 answers. Okay. So Pyramid has given a yes, that's okay. Okay. That says given the average force. So can you find the average retardation? Retardation is negative acceleration. Raja has given us the retardation force. Now find the retardation, the average retardation. Very good. Most of you are really trying. Raja has given the force to be negative. That Pyramid has given the acceleration to be negative. So if they say average retardation, retardation is negative acceleration. Pyramid, Raja, they have already. And Shaku, can you send your answer? What have you got? Raja, can you do the retardation? Retardation, you gave the force, but you have not given the retardation, the negative acceleration. So here you must bring in linear motion. Linear motion is very important. You must remember the equations. The v squared is equals to u squared plus 2as. You have to remember those equations of linear motion. You must remember them. You must remember that. That is just a hint. Abdi Malik has given the force. Okay. So let's wind up. Our time is now up. Let's check and see. So who is right? You can check and see that answer. So you can see here, since the car comes to rest, final velocity is 0. So the average retardation will be -5. And then the retardation force, average force, you have F is equal to ma. So you can see we have -6,000 newtons. So when you talk of retardation, you remove the negative. Retardation means negative acceleration. So you don't, if you talk of retardation, the negative should not be there. You remove the negative, put it positive. Then the braking force is 6,000 newtons. So that's how you're supposed to have gone about that. Thank you so much for paying attention. But those are the questions. Know how to use F is equals to ma. So today, the main concept I've emphasized is Newton's second law of motion. I've emphasized impulsive force applications, the real life situation. Remember how to explain the time of impact in relation to impulsive force. And remember how to apply the resultant force, F is equals to ma. So in our next session, we are going to give the meaning of impulse in relation to change in momentum. Otherwise, up to that, I want to stop there and wish all of you well.